Hello, welcome to this series on discrete calculus. A bunch of students reached out to me and told me I needed to make a set of videos, so here are 4 videos just for you. My name is Nakia. You can find me at CalcCoach.com. Please like, subscribe, comment down below. Let's get started. Okay, we take calculus, we understand that everything is about a function from a real number to a real number, single variable calculus. Well, now we have to look at discrete calculus, where we have sequences instead of functions. The inputs are only going to be natural numbers. The outputs can be any real number. So here's a sequence and here's a function, but they're familiar. You know them already. The function is y equals x squared, and the sequence is a sub n equals n squared. And so if I was to superimpose these two graphs, they'd be one on top of each other, and we have to deal with the differences between these two and see the need for discrete calculus. First up, of course, if you're doing calculus, you're going to talk about the derivative. Definition of the derivative, slope of the tangent line, limit as h goes to 0, f of x plus h minus f of x all divided by h. So what we're going to do in the discrete world, there's no h going to 0. The smallest h can be is 1. And so there's no limit either. And so take that formula, replace the h's with 1s, you got something that looks like this, but put it in the context of sequences, and you have what's called the forward difference, represented by a triangle symbol, and it acts on sequences, and it spits out the difference between the next term and the current term. Forward difference. And it's going to be our discrete analog to the derivative. All right, let's take a look at some sequences. All right, first sequence, multiples of 3. If you apply the forward difference to this, you're going to get all 3s. But let's look at it formula-wise. Take a sub n plus 1 and subtract a sub n. That's you replacing every n by n plus 1. So instead of 3n, you have 3n plus 1 quantity. Still subtract the original 3n and just distribute and cancel. And you have the formula that the forward difference applied to 3n is just 3. All right, great. Let's do it for this sequence. 2 to the n. Powers of 2. And if you look closely at it, after the first 10 terms, you subtract the successive terms, and you actually end up with this exact same sequence. Let's look at it formula-wise. Replace the n's by n plus 1s, and we'll have 2 to the n plus 1. Subtract the original 2 to the n, and we would then, with the exponents, break apart the exponent. So we have 2 to the n times 2 to the 1, and then we can factor out the 2 to the n that are in both of these terms, giving us 2 to the n times the quantity of 2 minus 1, but that's just a 1. And so when you apply the forward difference to 2 to the n, you get 2 to the n. This is analogous to when you apply the derivative to e to the x, you just get e to the x. Some people call 2 the digital version of e because of this. All right, great, we're doing good. All right, what about any other power to the n? Any other number raised to the n? Well, the same action is going to happen. You're going to be able to break up the exponent and factor out. And so in general, I mean, especially when r is equal to 2, but in general though, when you apply the forward difference to r to the n, you're going to get r to the n back, but it's going to be multiplied by r minus 1. Okay. All right, great. How about to 1 over n? So we write 1 over n plus 1 minus 1 over n. We should combine these fractions together. Multiply by what you're missing from the common denominator and cancel in the numerator. The n minus n cancels. You're left with a negative 1, careful. And so the forward difference applied to 1 over n is negative 1 over n times the quantity of n plus 1. Okay, great. How about the forward difference applied to n factorial? So we take n plus 1 quantity factorial minus n factorial. All right, well, we're going to break up the factorial. If you have n plus 1 factorial, that is n plus 1 times n factorial. And so we can then factor out the n factorial and be left with the n plus 1 minus the 1. The two ones cancel. And when you apply the forward difference to n factorial, you get n factorial back times n. Okay, great. All right, let's get some properties out of the way. Property of the forward difference. So you got two sequences and you got a constant c. Then you want to take the forward difference on the sum of two sequences. That'll be you taking the forward difference on each one separately and then adding. That's linearity, part 1. You want to take the forward difference on a sequence who is scaled by a constant c. We're going to pull the constant out and just focus on the forward difference applied to the sequence. That's linearity, part 2. You can put these two together into one property. And so the third property then is going to be how it works with the product of two sequences. It's a product rule. And so we'll get the forward difference on the a sub n times b sub n plus 1 plus the a sub n times the forward difference on the b sub n. And if you work that out, add in some terms, you get a three-term way to represent the forward difference on a product. So that's like our product rule. And then the quotient rule, if you need it, there it is. Okay. And so these are the properties of the forward difference. We'll end up using one of these later. All right. The forward difference has a partner called the backwards difference. So instead of a regular triangle with the base being on the ground, the base is up in the air. The vertex on the ground here, inverted triangle, where you take a sub n minus the previous term, a sub n minus a sub n minus 1. That's the backwards difference. Okay. E is an operator that will act on a sequence, and what it does, it just spits out the next term. Okay. And so if you're at the 8th term, applying E to it gets you the 9th term. It's a left shift operator. If there's a left shift operator, it's definitely going to be a right shift operator, and it's going to be the inverse of E. So if you're at the 8th term, applying E inverse will put you back at the 7th term. And we can combine these together. The identity is just leaving the sequence alone. You're at the 8th term, you stay at the 8th term. That's the identity operator. And the forward and backwards difference can be then represented in terms of the E's and the E inverses and the I's. Okay, applying the forward difference is applying the left shift and then subtracting the identity. And we can pull that out and factor out the sequence part. And E minus I accomplishes our forward difference. And then our backwards difference will be then accomplished with I minus the E inverse, the identity operator, and then we subtract the right shift operator. Okay, great. This is a good place to stop. There'll be 3 more videos coming. Thanks for watching. My name is Nakia. Remember, please like and subscribe and comment down below. I'm doing this for a group of students that aren't even my students. They asked me to make some videos on this, and so this is for you. All right, thanks.